Okay.
Let me look at the questions really quick.
Okay. And for those that are listening to the recording, we're just gonna go. It's gonna be a chill session, so we're gonna go through kind of like global wind patterns and the Coriolis effect, and then also talk about El Nino and La Nina a little bit.
So on question 9, it talks about like there's just like a bunch of vocab that I guess I'm not really sure of. Like they talk about trade winds and then Hadley cells, and I have no idea what those are because I don't think they explain that in the video.
Okay. Oh wow, they didn't explain those. Okay, so it was question 9. Okay, yeah. So I'm gonna share my screen real quick and go to the slides that I created. Oh no, Lynn dropped out. Okay. So okay, so I actually so there's this like phenomena that happens where in the northern and the southern hemispheres when hurricanes happen, um the hurricanes themselves actually like spin in opposite directions. So if you can see, one is spinning clockwise and the other is spinning counterclockwise. Oh, and let me know if my internet starts being
Mm,
maybe. Okay. So
okay.
the reason that happens is let's see. So I don't want to like play a video in the middle of here. Okay, so I'm gonna fast forward through and show you like the important parts of this video. So there's this thing called the Coriolis effect that happens. Let me show you real quick. Did they talk about the Coriolis effect?
Yeah, like
Okay.
when winds move when the as the Earth spins.
Yeah, so basically you see like the Earth is spinning like in this eastward direction, so it's always spinning in that direction. And then what happens is I'm going to blow this up and just narrate over. But so as it's spinning in that direction, the Earth, the if you think about from a physics standpoint, the Earth is spinning faster around the equator than it is around the poles. So this creates a phenomena which affects like our atmosphere. So if you were to like imagine it, like imagine if you were to throw a paper airplane from Texas and you were able to just like throw it straight, it would like in a like a perfect world where the Earth is not spinning, it would land dead like north above you. But however, like because the Earth does spin, it there we have to take into account like this gravitational force and like this momentum that's happening. And so as it spins, so remember we're spinning to the east always. And so when you spin to the east, they're gonna fast forward I think to another part where they show okay, so the paper airplane actually if you throw it up this way, it's gonna curve that way because it's as if it's the Earth's spin is taking the paper airplane with it. So that's what's making the trade winds kind of spin. Trade winds like not just go up and down. There is like a different movement to it because of the way that the Earth spins. Did they talk about that a little
So
bit?
I think so. So where are the trade winds exactly? Like, are they specific to a certain place?
Yeah, so the trade winds are the ones that are located here, the northeast and the southeast trade winds. So the trade winds are located like between the equator and the 30-degree lines.
Okay.
Yeah, so um basically whenever I don't think that the AP test is going to want you to know like exactly which ways things like which way the winds go in each of like the latitudes, but they're going to want you to know on the basis that like the earth's spin is responsible for a lot of the movement in which the trade winds like move.
And then the Had Hadley cells.
Oh, so the
They're
Hadley
basically
Oh yeah, go ahead.
Oh, go ahead. Oh, they're just like the little circles on the side, right? I think.
Yeah, so the Hadley cells, like, so like in a perfect world, we would have like because remember, hot air rises and cold air sinks, right? That's just how physics
Mm-hmm.
works. And so because of this phenomena, you have that's how like that's what moves the air around the earth, is this constant heating and cooling and rising and sinking. And so what happens is, like, because the air is most intense around the equator, you have a bunch of air rising here. And so in a perfect world without oceans or without land masses, it would just rotate like evenly throughout here. But because we have so many different elements, it actually turns into, so there's this one Hadley cell around the that goes from the 0 degrees equator and it goes to the 30 degrees. And so this Hadley cell is powered by the heating and cooling that happens at the equator. And so all of this hot air rises and it's really hot, and then um, it travels up away from the equator, and then eventually as it moves away from the equator it cools, so then it sinks again and it comes back. So it's driven by uh, the heating and cooling. And then same with this one's also driven by like extreme cold, and then it heats up just a little bit and then gets to extreme cold again. So these are the top two cells, the Hadley and the polar cells, are like the conveyor belts that move. And then like I want you to think of the Ferrel cells as like the cell that like is a cog in the wheel. So it's not so much heating and cooling a lot, it's more just like the air circulating because the other two cells are doing that.
Oh, okay.
Was that
That makes more
helpful?
sense.
Okay.
Yeah, because I thought like the Hadley cells were like I think the way that I got it from the video was like on a smaller scale, not exactly like throughout the entire Earth. But yeah, this makes more sense.
Yeah, I think they call all of, when they want to talk about all of them, they talk about like all of the Hadley cells, but really like to, and when they like become more specific, they're like these two are the Hadley cells. These two are the Ferrel cells, and then the polar cells are at the top and the bottom.
Okay,
Yeah.
that makes sense.
Yes. So, and then also the Hadley cells only exist in the troposphere. So the
Oh,
troposphere,
okay.
yeah, so they don't exist like throughout the entire like 500 kilometers that is our atmosphere. They only really exist in the bottom like 11 kilometers.
Oh, that's probably where I got it mixed up.
Yeah, they're not super, yeah. So then like, okay, so like these are things that will help us like orient ourselves when we talk about El Nino and La Nina. So like um we want to always think about like warm, when there's warm air, so like the warm air that happens at the equator, when it rises, it creates a low pressure system. And then these low pressure systems create rainfall. So like however you want to like try to remember that, warm air, low pressure, rain, warm, low, rain, or something. And then the opposite is that cold air, when it sinks, it creates high pressure systems, and it actually makes like clear skies or like no rainfall. So I would write that down on like a cheat sheet if you're gonna for like unit 4 or something.
Okay.
Okay. So let me know when you want to move on to, or Huynh, do you have sorry, Huynh, do you have questions about kind of this very short crash course on how our atmosphere works?
Not really.
Okay. Okay, cool. um do we want to move on to, let's see, is there, oh, and then there's like a video on my slides about it that I think explains it really well. um yeah.
Are they posted in the Google Drive?
Yeah, so the Google Drive has all the slides. Um,
Okay.
yeah. Okay, so do we want to talk about, do the seasons make sense, or do we want to go over that too?
I mean, we could.
Or would you rather spend time on El Nino and La Nina?
Um, we. I mean, maybe just like a brief explanation just to make sure I have everything.
Yeah, no worries. Okay, the season, so with the seasons, like the earth is constantly on a tilt and it moves around the sun on that same tilt. And so like the tilt is kind of what creates the earth's seasons. Like if you imagine if the earth was just like straight up and down, um like the sun would equally, the sun's radiation would equally hit all of the places like throughout the year evenly. So we wouldn't have seasons, right? So like if so this is the picture that you often see on the AP test, and what it wants you to know is like to orient ourselves, like this over here is where what the earth looks like in December. And so remember, the earth is constantly spinning but on that tilt. And so you can see that like there's more light hitting the southern hemisphere in December, which is kind of why like Australia has its summers during December. So that's when Australia is like the hottest, when it's got like the longest days of the year, because Australia is down here, right? And so like our winters are in December because we get the least amount of radiation up here. And then vice versa in June. So like you can see that the solar radiation travels like the least amount kind of like in this area. I think essentially that's kind of what they want you to be able to distinguish, is like how long the days are in various points of the year, and like how and what like the seasons are in various points in the world. Okay, I think that's the extent of like what they want you to know on the AP test. Did you have like run into things on the multiple choice that tripped you up about this?
I'm just looking back at the questions. No, they seem pretty straightforward to me.
Okay. I did notice that they tried to trip you up in this question on the multiple choice because there was like a minute difference about like the amount of radiation you got versus like Australia being closer to the sun. And
Mm,
like it was one of those things where like both of the answers were correct, but one of them was more scientifically worded. So like that was like splitting hairs.
yeah, I also thought like, yeah, because it doesn't really have to do with like the distance. It's more of like the tilt, I
Yeah.
guess.
Yeah. But I could like if I were if I were taking the test, I might have picked like Australia's closer to the sun. All right. Okay, so that's solar radiation. Um oh, and I think just like just to reiterate that low pressure and high pressure, like so I hopefully they talked about in the videos like the reason the equator is so wet and so warm is because like you have constantly air rising, which means you have low pressure systems, so a lot of rainfall. And so like in the same in the same vein, you have a bunch of deserts at kind of like that 30-degree latitude line because the air is like always sinking, kind of where the Hadley and the Ferrel cells meet. And so then you get a bunch of like places that don't get a lot of precipitation. So like the Sahara, the Gobi Desert, the Atacama deserts are like at like these 30-degree lines. That's a little bit of like a pattern you can kind of sense.
Mm-hmm.
Okay. Do we want to talk about El Nino and La Nina?
Yeah, sure.
Okay. I really love El Nino and La Nina. I think it's fascinating, but like my students last year hated El Nino and La Nina. Okay. Okay, so let's skip. Okay, so El Nino and La Nina, what do you know about it already? Or like, how did they paint? How did they like try to teach it?
Um, I don't know. I feel like they talked about like weather and then pressure and also like like winds like all in one. And then I know that El Nino in certain areas or everywhere it's kind of has the opposite effect of what it would normally be, and then La Nina is a more enhanced effect of what it would normally be. Um, I think it's just hard for me to like remember all of the places where it's normal and not normal.
Yeah, totally. Okay, so yeah, so El Nino and La Nina, like for one, if you haven't seen the videos, it's kind of like there are these events that happen every like 3 to 7 years. So it's like almost, and it's naturally occurring where like the weather patterns and like the climate, like the weather patterns will change because of the winds and the ocean. Um, okay, I won't explain this map. But okay, so let's talk about like a normal condition that's not under El Nino and La Nina. So, so Caitlin, stop me if you like already are familiar with this, and I'm just saying things. But so remember when warm air rises, it creates rainfall because it creates low pressure. So in a normal year, you have these trade winds that kind of converge at the equator. So like these trade winds, let's see if I can write on here. Oh, I can write on here. Okay. So these trade winds, so to orient ourselves on this map, this here is North America. This is South America. And then this is almost like a cross section of the ocean. So this is like the deep ocean down here. This is Australia. And then this over here is like Asia, over East Asia over here. So we have the equator here along this kind of like this like arrow, the white arrows, and the trade winds are converging on the where the equator is always. So in a normal year, you have like trade winds that will blow and will move the surface ocean water, and so what happens is, remember, the surface ocean water is a lot warmer, and so because of the sun, and so it's as it pushes this ocean water, these trade winds, it's pushing all of that warm water towards Asia and Australia. So as it does that, of course, the ocean, there's so much water in the ocean that it affects the temperature of the air. And so as all of this warm water kind of starts pooling on this side of the Pacific Ocean, you have like, the air heats up, and as the air heats up, there's rain, yada yada. Um, so on the other side, so because you have water, like imagine if you're in a bathtub and you're pushing the water onto one side, there's going to be water at the bottom of the bathtub that starts moving to the other side, right? Otherwise, the ocean would be at an angle. And so as the winds push warm water over towards Asia, there's cold water from the bottom, like lower down in the ocean, that starts being like pushed over back towards North America and South America. And so they call that upwelling. That's a vocab word they're going to want you to know. And so this cold water upwells towards North America and South America. All right. So this is like a very natural thing that happens every year. Okay. So does that feel good, solid?
Yeah.
Or still, okay. All right. Then, so in an El Nino year, what happens is the trade winds naturally, they're just weaker. And so what happens is you have all of this warm water that just kind of pools at the surface. And even like because there's not trade winds that are pushing it back, some of it even drifts towards like North and South America. And so because you have all this water, this warmer like ocean water that pools in the center, then you get like storm systems and you get like low pressure systems that kind of accumulate at the center of the ocean, and then even kind of like towards the sides. So normally you'd have heavy rains over here on this side, but instead during El Nino years, you have like kind of wetter seasons over in the North and South America side. Okay, so another thing that they want you to think about is what is the effect of what happens when there's not as much cold water upwelling onto the coast? So like where do you think there's the most nutrients in the ocean?
At the bottom.
At the bottom, yeah. So that kind of is trippy because like there's so much competition for nutrients towards the top because most of the organisms like live near the top of the ocean. But so that means that that leaves at the bottom of the ocean has a bunch of nutrients that is not being used and eaten. And so the upwelling is actually really healthy for the North and South American coasts because that's just a bunch of nutrients that gets like kind of upwelled and recycled upwards. But then because there's not as much upwelling during El Nino, like the coast is not getting that nutrients. All right. So trade winds are weaker. There's less upwelling and less nutrient rich water. And so like you can think about like the fisheries that year will probably not do as well, which is a bummer. So fisheries like hate El Nino. There's also like less water that hits like India and Australia and like kind of the Asia region. And then El Nino happens like more frequently than La Nina. So like probably closer like every 3 or 4 years, El Nino will happen. Right. So did I go too fast on that?
No, it's okay. I think I was kind of confused on why it would reduce the number of monsoons rather than increase them.
Oh, okay. Well, so it would reduce the number of months because monsoons is just like heavy rains, right? Not just, but
Hmm.
it's heavy rains. And so because there's not as much warm water over like accumulating and concentrated over here, the warm water is instead like kind of vaguely distributed across the ocean. So like then there's less intense heating of the air and therefore there's less intense rains. Instead the rain is kind of scattered like across the entire like equator.
Oh, okay.
Yeah, so then like because there's less cold water on this side, it's warmer and so then there's more precipitation in like the North and South Americas.
That makes sense.
Okay, cool. So do you want to move on to La Nina?
Yeah, sure. If there's no other questions, that's fine.
That's right. So how do you feel right now? Do you have questions about El Nino?
No, I understand what you're saying.
Nice. Okay. So I guess like, so Caitlin and Quinn, do you want to try to explain La Nina? Looking at this like diagram, try to explain what's happening and how La Nina works.
Um, so with La Nina, it looks like the normal conditions picture. It just seems like a lot more of like the rain is towards Australia and the eastern countries. And then also like if you look at the bottom, the upwelling also seems a lot steeper. Like there's a ton more upwelling towards the North and South Americas. And yeah, it just looks like it was a lot more pushed over to the Australian side.
Yeah, and what causes it to be like much more intensely pushed over?
Um, I guess the trade winds are just rotating either faster or more intensely.
Yeah, they're just stronger that year for some reason.
Hmm.
Yeah, that's basically it. And so then because like you're saying there's a bunch more upwelling, so then there's a bunch more nutrients. So then the fish are like popping off over in the North and South America. And so like La Niñas are a really good year for fishermen usually.
What are the things that usually, like, do trade winds just spontaneously get stronger? Like, is that just a thing?
I don't know. Honestly, I have no idea. I didn't look into that. I wonder if it has something to do with like I think it has something to do with the way that the earth travels around the sun and how
Mm.
it is different every few years.
Because it is usually predictable, right?
Yeah, yeah, usually people can yeah, I wonder I should look that up. That's a good
For
question.
I feel like I've heard on the news like the meteorologist talking about El Nino and La Nina. I was like, am I becoming a meteorologist now? But yeah.
Basically. Yeah, I think that the phenomenon is really cool. Oh, bye, Juan. No worries. Hey, this is you're. I'm proud of you for even being here, and you should be proud of yourself too.
Bye, Miss Tao.
Bye, Juan. Okay. Well, that's El Nino La Nina. That's kind of. Oh, and here are two pictures of like, kind of like comparing them side by side from like an aerial view.
Oh yeah. I feel like this makes a lot more sense than the other one.
That's good. Yeah. So then like if you look at it from this point of view, like during El Nino years, they're trying to depict like it's wet and warm throughout this entire like region. So then this area is kind of drier. Um, and then this area is like a lot wetter.
Mm.
Versus like La Nina, where it's like dry and cool here, because remember the ocean's like cooler, which means there's like not as much precipitation. But then that means all of this warm water is like being pooled here, which creates like a lot of like heavy rains.
Mm.
And then over
Okay.
here it's drier.
Mm-hmm.
Yeah.
And I think there was, I don't know if you have this on the slides, but they also had like another diagram of like, I forget if it's, I think it's the wind that goes through North America, like from like up near Washington, and then it just like swerves around to the East Coast.
Oh, was that? I'm trying to. This one?
I think it,
Oh no, that's not it.
I don't know, I
Do you
think
want
it
to
was
show
in
me?
the, yeah, let me just look for the video.
Uh,
Hold on, this might take a little while. I don't exactly remember where it is.
It's okay.
Oh, okay. Do you want me to share my screen?
Oh yeah, let me give you co-host. Yes. Go for it. I like low-key love Unit 4. I'm such a nerd for this stuff.
I feel like Unit 4 was probably the toughest for me.
Yeah, it is like a lot of
Yeah.
new concepts. La Nina weather patterns.
What's like
Oh,
this system? I don't, because I know they talk a lot about like in the Pacific, and I think I was kind of confused on why they were talking about it here.
I think they're trying to say that like usually like in normal years, you know that the Hadley cells, they kind of stay pretty uniform and like in their lane essentially.
Mm-hmm.
But like during El Nino and La Nina, the like they start like dipping, like the polar cell starts like dipping downwards, and so then the polar jet stream does as well. I don't know how
Okay,
relevant that is.
and the polar jet stream is the winds.
Yeah, so it's like it's the winds, and they categorize the winds because like they come from different places, and so their density and like their temperatures are different. But I like haven't seen a question on the AP test where they have you like distinguish the different winds by like memory.
Okay.
That would be absurd.
Yeah.
Oh
Oh yeah.
yes,
And then
they
this.
have that.
Okay.
Yeah.
I think I'm good. Yeah, I think I was just tripped up by this because I didn't know how it correlated.
Yeah. This unit, I feel like this unit is more like earth sciencey type of stuff rather than like specifically environmental science.
Yeah, I think this is just like a lot more unfamiliar to me. Maybe
Yeah,
that's why.
that's real.
Okay.
Yeah. Did you have questions about the FRQ?
Um, let's see. I did just do the FRQ last night, and I
Oh wow.
probably have to like compare it to like the answer key.
Do you want to
But
walk through like some of the questions that you felt uncertain about?
yeah, sure.
Okay.
Okay. I guess we can start with the first one. Do you want me to like share my screen or just
Um,
talk about it?
yeah, you can share your screen and then we can talk about it. If that feels comfortable. And I'll pull up the answer key. I thought these multiple choice were these FRQs were kind of hard, honestly.
Yeah. Some of them had like trippy wording.
Yes, very trippy.
Right. So this one, first one.
Yeah. So that one, so like when it says producing weather, always think of the bottommost layer. So like the troposphere.
Oh, okay. So then the stratosphere would just. Is that where the ozone layer is?
Yeah, that's where the ozone layer is. That's where airplanes fly. Um yeah, I cannot believe their multiple choice was them like asking you to memorize all of the different layers of the atmosphere. That was really stupid. um yeah. Okay.
I think here I was just I guess like this phrase, the mixing of liquids and gases, because I was thinking of like the ozone layer and how I don't know,
Oh
maybe.
yeah. That yeah, I think they were trying to trip you up with that one, for sure.
Yeah, but I'll look for weather next time.
Yeah. Yeah, the second one's great. So it says whenever you see the word describe, you did a great job where it's just like a simple like this happens and therefore these other things happen. So that's great.
Yeah, I guess I wasn't sure if I should be more specific.
I don't think so. I think that like keeping it shorter also allows you to finish more FRQs.
Okay.
Yeah.
Alright. So this one's on watersheds.
Yeah. So this one was so what did you think?
Um, well, I heard geology, and then I guess the first thing my mind went to was like human activity, because that does affect it. But then when they talked about geology, then I was like, okay, like the steepness of the slope, because this is like a mountainous, um, what is it? A mountainous watershed, and then also like the number of rivers, because I remember them showing me examples of like wetland watersheds versus like mountainous watersheds. So yeah.
Yeah, you nailed it. It's wow, that's such a good answer. Like the steep, so like if water runs off of like mountainsides really quickly, it's not soaking into the ground very well and therefore not recharging.
Oh, I think I said that it would be more efficient if it was. So I don't know. I guess because I guess I pictured it as like groundwater at the end of the rivers.
Oh. Oh, you know what? That works as well. You're thinking about it in a different way. Yeah. Let me see. Let me see the answer key if they nitpick about that. I think that that's a great explanation because you could give either explanation. Oh my God, where's the answer key?
So is groundwater basically like just patches of where the water or like just the layer of water underneath the soil everywhere?
Yes. Yeah, groundwater is like it's the like underground like river basically.
Okay.
So the answer key says, is this part B, number 1, right?
Part A, or yeah, part B, I.
Okay. So they talk a lot about geological formations. Okay, so here it says that you want to talk about, they're talking about geological formations that have like rock that doesn't allow for permeability. So like
Oh,
and
like
or
clay?
yeah. Oh my god. Yes. And then it like sometimes will, so you know how like they always give like, 10 different answers that they would accept.
Mm-hmm.
So I would say if you're talking about geology, I want you to think of rock.
Okay.
So I would talk about rock that allows for water to move through quickly. So like, use like buzzwords like permeable or like porous. 'Cause that's what they kind of want you to talk about.
Mm-hmm. So soil composition. Kind of.
Yeah, but remember rock is like soil comes from rock. And so they're asking you to talk about
Okay.
rock. The lake at Point A is the primary recharge. Yeah,
Um,
it's sand.
and here's A.
Yeah. Yep.
I think I kind of guessed on this one.
Really? Because it just says the response should indicate sand. So you know that.
um, yeah, I think. Let's see. I think when I think I was confused because I again thought that the aquifer was like at the bottom of the watershed. Um, and I was kind of confused if they were referring to like this aquifer or Lake A as the aquifer.
So aquifer is always underground.
Okay.
Um,
And then
yeah.
okay,
Do you
and the
feel a little
maximum
bit
rate of
tripped up as to
recharge.
what groundwater is?
Um, yeah, I think it's because I've always thought of it as like not exactly like spread out throughout a region, but I'll have to like relearn that.
Yeah, so groundwater, just think of it as like the layer. It's just water that's underground, and so it is spread out throughout the region.
Okay.
Yeah. Does that logic not sit well with your understanding, or like how this picture
Mm,
kind of is?
I don't know, maybe just because of the fact that it has slopes, and I think of like water running downstream. But yeah, permeability. Yeah, I'll think of it more as like permeability rather than like gravity.
Yeah, I think groundwater for the most part. So like my understanding of groundwater is that it does sit at like an even level. And so like if you're on the top of a mountain, the water has to permeate like a lot farther to reach the groundwater. And
Mm,
usually what happens is that water just kind of runs off, and then the permeating really happens in like the flatter areas like around rivers and stuff.
okay.
If that makes sense, if that makes sense.
Yeah, that makes
Okay.
more sense.
Okay. So yeah, sand is absolutely correct.
Yeah, because I was just looking at maximum rate of recharge, and the largest particle would be sand.
Yeah. Ooh, you used buzzwords, which is awesome. Like porous. They would love that. Oh my god, 1 second. Sorry.
It's okay.
Sorry, my doorbell just screamed at me. Okay. That's great. Let me check the answer key to make sure that they don't have. Oh yeah, it says the soil should have high porosity because it should have a large number of pore spaces for water, or it should have high permeability, or it can have a high percentage of sand because sand is very permeable.
Okay.
Yeah.
All right. So I didn't have to be too specific.
No, this is perfect. A lot of these, when it says describe, it's like one sentence long is usually what they're looking for.
Okay.
All right. Yes, amount of soil. Nailed it. And then let's see. Perfect. So they want you to talk about how it's like undisturbed.
Oh, okay.
That's great. So you're saying like it hasn't been altered. So you're saying the same thing, which is great. And then the next question, like
I have no idea.
that one is crazy because you would have to learn like unit 6 in order to have answered this question. So I should have been more detailed in the remembering that. So don't worry about that one. That one, like you can like look back on after learning unit 6 and be like, oh, like now this question makes sense.
Okay.
Yeah.
But it's like, all right.
So
It goes more into like agricultural methods.
yeah, they talk about like all of these names of agricultural methods that are like more sustainable. But yeah, so you'd have to use those like new vocab words to answer that question.
Okay.
Great. Yeah, they totally said that they accept. Let's see what is that's. Yeah, so they talk about the amount of vegetation. Amazing. That's perfect.
What were some of the other answers?
So some of the other answers is like if the topography of the land was not as steep. So like if there wasn't like because when the land is steeper, then the water runs faster off of it, and so when the water runs faster, it takes more like dirt with it and more soil. So if the slope and then ground cover. Oh, and then if the soil was denser and like less porous, because if you think about it, like sand gets carried really easily, but like clay, something like clay gets carried less easy. Yeah.
Okay.
That's about it.
So land surface can also mean like land composition.
Yes. This one seems to be a stretch of the imagination and include a lot of different things.
I also feel like sometimes I like read a little bit too much into it, and then it ends up being like super specific to a specific answer in my head.
But honestly, like sometimes the questions are kind of specific, so that could help you in certain questions.
Okay. Alright,
Cool.
let me just submit this. Alright. You don't really grade the FRQs, do you?
I don't grade the FRQs because I post the answers on the answer keys. So like if you finish the FRQ and you're like, I hated this answer, that's when I'm like, I would love to talk to you about to like figure that out.
Okay. Yeah, I think I'm just asking for the purpose of like looking back on it. I'm not sure if I'm like able to reopen the past FRQs. That's why. Yeah. But I don't like having the assignment like incomplete. So I just try to like submit everything.
That's real. Do you want me to bump it back to you so you can kind of see it again?
Yeah, maybe just this specific FRQ.
Okay.
I think the rest of them I was okay.
Okay, I will try to figure out how to do that. Cool. Is there like anything else content related before I stop recording? Yeah, I'm trying to think of like the really weird multiple choice questions that they put.
Yeah, let me look back at my multiple choice.
Let me look through them too to see if what was trippy.
Okay, the picture, the diagram of the Andes Mountains in Peru.
Yes. I even paused at that one and was like, this is wild. Okay. Here, do you want me to share my screen real quick?
Sure.
Okay. So let's see. Okay, so they're asking you, let's see, what there were 2 questions on this, right?
I think 3. 3.
Yeah, okay. So the first one talks about the rain shadow. So are you familiar with the concept of the rain shadow?
I think it's like when there's precipitation and one side of the mountain gets like a ton of rain and a ton of vegetation and the other side is dry.
Yes. You would have needed to know that off the top of your head. So I'm glad that you did. Yeah, so like basically all of this warm air comes from over, I'm trying to see if I can draw. So all this warm air comes from over here, and they're saying that it goes over the mountains, and then all the air gets dumped on this side of the mountains, and then on the other side is super dry. So that's the concept they wanted you to know there.
Okay. Does rain shadow also have to do with like land masses that are near water? Because like the low pressure systems in water would make it precipitate?
I think yes. Honestly, that kind of, you just stumped me. I think yes. But I think in this case, regardless, because the Andes are so tall that like if you think about if there's a mountain and you have all of this like warm air that runs up the mountain and cool, and then like it rains and then it moves over and it's this super super dry air. And
So the height of the mountains kind of like overrides the fact that Peru's near water.
I think so. I think there's probably more nuance to that. But
Okay.
yeah. But I think right now it's like this mountain range is massive, the Andes is. And so like it's going to create these huge rain shadows on the other side. Okay, I'm looking at the other answers to see if there was something else in here that was they try to trip you up with. The cold Peru current brings dry air to the west coast. Cold.
Does it bring cold air up that way?
So something they want you to know is that because the air circulates this way on this side, but the air circulates this way on that side. So the air is already really warm because it's at the equator when it gets into like the South America area, right? And so what it's trying to say here is that the air is like cold and then hits this side of the continent. So it's like this air is warmer and this air is colder and it warms up like kind of over here.
Okay, I see.
So I think that's a difference they want you to. I think that's a difference that is more important in the other 2 questions. Compared to the East Coast, less water available. That is not relevant. Okay. Windward, I don't think is like a vocab word that is very important. So, okay.
Windward. It has to do with like rain shadow effect, right?
Yeah, windward. Yeah, I'm trying. Do they talk about windward at all?
Yeah, windward is like the side closest to the ocean, and then
Versus
leeward
leeward.
is inland.
Yes. Okay. Okay. So let's do you feel comfortable moving on to the next question? Okay. So this next question talks about more moderate climate. So this one, I think the answer was that it talks about the Brazil current, right? The East Coast would have a more moderate climate because of the Brazil current. So first we have to think about like what did you like when you read moderate climate, what did you think?
Like more consistent temperature and weather,
Yeah.
I guess. Not as
Dope.
much fluctuation.
Yes. 100%. Yeah. So that's like a vocab word. I mean, in and of itself. So like steady temperatures rather than like the Atacama Desert, which is just like super hot, super cold.
Mm-hmm.
So they're wanting you to recognize that like the moderate temperatures come from the fact that like there is warm air coming in this way. And so like Brazil is being hit with this like warmer air, while in Peru you're being hit with this like colder, um, the colder temperatures.
Mm.
I'm trying
Could
to.
it be moderate climate even if it's like consistently cold temperatures and consistently warm temperatures?
I think moderate also implies that it's like not there's no extremes, or there's not as
Oh,
many
okay.
extremes. So their explanation is that the Brazil current comes from the warm south equatorial current and equatorial waters. So this warmer water would influence the climate and make the East Coast warmer than the West Coast. So it's just saying like because the water rotates this way, the air is like it's heating up the coast.
Mm-hmm. Yeah. I think for this one I thought it was B because like the Andes Mountains would kind of separate the like the climate, I guess. But now that I'm looking back at it, I could have paid a little bit more attention to like the wind currents too.
Oh, I see. Yeah. So it's saying that since the for B it says since the West Coast experiences a rain shadow effect because of the Andes Mountains, the climate there would be very arid rather than characterized by moderate rainfall.
Oh, moderate also takes into account rainfall.
Yeah, so like everything's like about like I guess just like a normal, not normal's a wrong way to put it, but like not too much, not too little.
Like best for life, or get I guess.
Yeah, yeah. This
Okay.
is it's a very vague term. I don't love it.
Mm-hmm.
Okay, cool. So that feels comfy.
Mm-hmm.
All right. Then the last one. Um, oh, so this one talks about so whenever they talk about like rivers and like freshwater, you want to be thinking about rain. Because that's really the origin of, you know, most of our bodies of fresh water.
Mm-hmm.
Um, let me know what feels confusing.
Let me just read through the answers. Okay, so I guess it's like the reasons of which areas would have more rivers. I don't
Yes.
really know that.
So the areas that have more rivers are the places where it rains more.
Okay.
So, because all of our fresh water comes from rain, essentially.
Mm-hmm. And then I would have to like put together the pieces that warmer air would mean more rain, and then that would like lead to the Brazil current.
Yes, exactly. You're remembering the warm air, low pressure, more rain.
Yeah.
Yeah, and then you already you already know that the Atacama Desert is on the west side, and so like
Mm-hmm.
automatically you're like, well, there's not a lot of rivers in this desert.
Mm-hmm. How about the last option? Would that have anything to do with it?
Um, so no, well, no, because think about so just the principle is that like rainfall causes freshwater systems, and so
Mm-hmm.
like the sun drying air, it doesn't really matter because if you not drying air, if you dry up a river, that water vapor still goes into the atmosphere and gets rained down back
Okay.
into the land. So the water is just changing form, but should be recycled back onto the land.
Oh, okay.
Yeah,
Mm-hmm.
I think. Well, their
That makes sense.
explanation was that the mountain will receive sunlight at different times during the day. That feels incomplete. Oops, I don't know what happened. Okay. Oh, they logged me out.
I think that's all of the questions I have for like multiple choice.
Okay. I think those are the ones that I paused most on that were very weird. Okay, cool. Then I will stop recording.